Congratulations, students. You've made it to the very last section of the quadratics chapter. We're going to be learning about the quadratic formula and the discriminant. So, the essential question, what predictions can I make about a quadratic function, its graph in particular, based on different parts of the quadratic formula? Now, you have seen the quadratic formula before. It is this. So, what the quadratic formula does is it says, hey, if you have a function in standard form, so ax squared plus bx plus c, and if you set that function equal to 0, the solutions, what x equals, you can find by plugging the coefficients of x squared, x, and the constant term into this formula. So what we're going to do, what our strategy is, when we're solving equations, if we want to use the quadratic formula, we're going to make sure they're equal to 0. We're going to find the coefficients of x squared, x, and we're going to find the constant term, and we're going to plug them into this formula. Now, there's another part of this formula that's important to us that we're going to be looking at, which is the stuff under the square root. Remember how we've been talking about how things under the square root, if they're positive, they kind of behave properly. We can put them into our calculators. If they're negative, they're imaginary, and so there are some special rules associated there. And whether there is a positive or a negative under the square root is going to affect the way the answers work out. So what is under the square root we call the discriminant. And we're going to look at exactly what the discriminant deals with, but just for now, for future reference, discriminant, just the stuff under the square root, b squared minus 4ac, and it's going to tell us some things about the quadratic function. Let's do an example. Okay, x squared plus 3x equals 2. Now, like I said, the first thing we need to do is we need to get a 0 on one side. So let's subtract 2 from both sides. Now I have x squared plus 3x minus 2 equals 0. Nice. So now I'm set up to use the quadratic formula, but I need to identify my coefficients. The coefficient of the x squared term is a. So in this case, a is 1, right? There's that invisible 1 there. B is the coefficient of x, so b is 3. And c is my constant term, so c equals negative 2. And now that I know these things, I can plug straight into the quadratic formula. So, okay, you need to have the quadratic formula memorized, very important. I have it memorized because I knew I needed to memorize it. So, negative b plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is negative 2. All of that is over 2a, so 2 times 1. Now we can simplify some things, and we need to use good order of operations. Good order of operations says do parentheses first. I don't really see any parentheses I can simplify here, so it says do exponents second. And as it turns out, this square root is counted as an exponent. Did you hear my wife sneezing there? I was very angry at her for disrupting the learning. Anyway, we're simplifying some things under the square root. So, yes, let's see. I have 3 squared, which is 9. And then I need to worry about the multiplication. Negative 4 times 1 is negative 4. And negative 4 times negative 2 is positive 8. And if you're like a little sketchy about doing the stuff under the square root, if you just put 3 squared minus 4 times 1 times negative 2 into your calculator, that can give you what's under the square root. And I would recommend doing that first because the order of operations can get a little bit tricky. So whether you do things mentally like this, 9 plus 8 is 17, or if you put this into your calculator, you should get 17. Either way, we have 17 under the square root, and I would always recommend simplifying that first. On the bottom, 2 times 1 is just 2. Now, if I had asked you to leave this in radical form, we would be done right now because I don't know what the square root of 17 is. And it is a prime number, and so we can't pull out any perfect squares. So this could be an answer. But if I'm looking in the context of a graph, this doesn't really help me graph anything. And so let's see what the answers are in decimal form. If I want to convert this to decimal form, I would need to split this into negative 3 plus the square root of 17 over 2. And negative 3 minus the square root of 17 over 2. Now, I would recommend putting this into your calculator all in one step, but definitely make sure to put parentheses around the top of the fraction. Otherwise, your calculator will only end up dividing the square root of 17 by 2, not the entire top of the fraction by 2. When you put both of these into your calculator, you should get that this top one rounds to 0.56, and this bottom one rounds to negative 3.56. And so here would be my two solutions of x if I wanted you to give the solutions in decimal form. Now, let's think about what this tells us on a graph. We just set the equation equal to 0, right? In other words, think about an equation in standard form. Since my equation is set equal to 0, isn't that kind of like saying, hey, I have a function y equals x squared plus 3x minus 2, and the y is equal to 0? So as it turns out, since the y, if we're thinking about this as a function, is set equal to 0, these are the x-intercepts. Because if I have a point, 0.56, comma 0, and if I have a point, negative 3.56, comma 0, these are the x-intercepts. Let's graph them. Over 0.56, up 0. Over negative 3.56, up 0. Nice. So those are the intercepts of the graph. And since my a is positive, my graph is going to look something like this. It's a smiley parabola because the a is positive, and it's going through those points on the x-intercept. Very nice. Now, let's take a look at the discriminant. Remember, we said that the discriminant was this number underneath the square root, right? So in this case, my discriminant is positive 17. And we're just going to keep that in the back of my mind for now. We have a discriminant of positive 17. That gave us two real roots for the function. All right, let's take a look at another example, and we'll start moving more quickly through this. Here, if I want to get a 0 on one side, I need to subtract 12x and add 9. That's going to cancel here, and my equation will be 25x squared minus 30x and plus 9 equals 0. Okay, my a is 25, my b is negative 30, my c is 9. Let's plug into the quadratic formula. Negative 30 plus or minus the square root of negative 30 squared minus 4 times 25 times 9, all over 2 times a, which is 25. Okay, lots of things to simplify here. First of all, this negative 30, obviously the negatives will cancel to just 30. Also on the bottom, I have 2 times 25, that's 50. And remember, I recommend you simplify the square root. If you plug negative 30 squared minus 4 times 25 times 9 into your calculator, it will know what to do. That should be 0. Now, this is very interesting. Under the square root, we have 0. What's the square root of 0? Isn't it just 0? So this function is 30 plus or minus 0 over 50 because the square root of 0 is 0. Now let's think about what that means. If I split up my problem into the plus and the minus, I have 30 plus 0 over 50, and I have 30 minus 0 over 50. Are those two different things? Isn't 30 plus 0 still just 30? And then 30 divided by 50, I could simplify to 3/5. Same thing here, 30 minus 0, it's just 30. 30 over 50, 3/5. So here's the deal with this function. Notice, what was the value of the discriminant here? What did we have under the square root? We had a discriminant, or a value under the square root of 0. What did that cause to happen? I have a duplicate answer because the plus or minus didn't matter because it was just plus or minus 0. How would I graph this? Well, the 0 of the function would be just 3/5. It's a duplicated 3/5. This is an upward facing parabola, and so what that means, since it's a duplicated 3/5, is that our vertex is right on the x-axis. So discriminant of 0, duplicated root, vertex is the 0. The function just comes down and just barely touches the x-axis, and then it goes back up. So keep those things in mind. Discriminant of 0, just one root for this equation, just one x-intercept, which is the vertex. One final example. Okay, as usual, let's subtract 5 from both sides. So I have negative x squared plus 4x minus 5 equals 0. Okay, it looks like my a is going to be negative 1, my b is 4, my c is negative 5. And let's do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. Let's simplify some things. I have negative 4 plus or minus the square root of. Okay, if you put this into your calculator, you should get negative 4 under the square root. And remember, I advocate putting this whole thing into your calculator. 4 squared minus 4 times negative 1 times negative 5 is negative 4. This is all over negative 2. Okay, so let's think about what's happening here. First of all, look at the discriminant, negative 4. My discriminant here is negative 4. Since I have a negative discriminant, since I have something negative under the square root, that means imaginary numbers are going to show up, right? Do you remember how the square root of a negative works? Hopefully. The square root of negative 4 is going to be plus or minus 2i. 2, because the square root of 4 is 2. I, because I have a square root of a negative, and I is the square root of negative 1. And this is divided by negative 2. Now I can simplify some things here. If I distribute my division, negative 4 divided by negative 2 is just 2. And plus or minus 2i divided by negative 2. Let's see what would happen there. 2i divided by negative 2 is just negative I. If I have negative 2i divided by negative 2, that'd be positive I. So anyway, the point is I have plus or minus I. And these are my solutions. I don't know how to simplify this anymore because I and 2 are not like terms. So what's going on with this parabola? What does it mean to have imaginary roots? Can I come over here and graph these imaginary roots? Where, like, is it at 2? Is it at negative 2? Well, no, it's not, because it's not just 2, it's 2 plus I. So as it turns out, I cannot graph these on the x-intercept. And in fact, that means that the parabola is not even going to cross the x-intercept. So let's think about what the graph looks like. This is a downward facing parabola because my a is negative, and we know that it does not cross the axis because I don't have real roots. I have imaginary roots, and I don't know how to graph those on the x-axis. So if you graphed this in your calculator, it would look something like this. It is a quadratic that does not cross the x-axis, and instead of real roots or real x-intercepts, I have 2 complex roots or 2 complex x-intercepts. So remember, we had a negative discriminant. It gave me 2 complex roots. Interesting. So guys, I know this was a long video. Make sure to remember the quadratic formula. Make sure to have it memorized. And as the summary, I just wanted to tell you, what does the discriminant actually tell us? It depends on the sign of d. If d is positive, that was like the first example. And keep in mind what it meant. It meant that there were 2 roots. So discriminant was positive. There were 2 roots. So, whoops, sorry. Oh no, I lost it. Okay, I regained the PowerPoint. That was close. So if the discriminant is positive, it means that there are 2 real roots. My quadratic is going to cross the x-axis. If the discriminant was 0, that's like this second example. And remember, if the discriminant was 0, we have a duplicated root. In other words, there is just 1 real root, and that's a situation where the quadratic comes down and touches the x-axis and then goes back up, but doesn't actually cross. If the discriminant is negative, that was like this last example, that means the quadratic doesn't touch us all, and instead of having 2 real roots or 1 real root, I actually have 2 complex roots, meaning that it involves an imaginary number, and that would be the quadratic does not touch the x-axis at all. Well guys, this was a record length video. 15 whole minutes of your time are gone, but I hope I gave you a lot of information there that is helpful for you. Memorize what happens with the discriminant, memorize the quadratic formula, and it should be a pretty easy lesson. See ya.